All right, hello everyone. Welcome to the second part of the video for section 3.2, continuing on with our study of quadratic functions and identifying different properties of theirs. Okay, so let's do a little bit more practice related to the vertex of a quadratic. So we're told in the first question up here, we're asked to write an equation for a quadratic function with a vertex at -2, 3 that passes through the point 0, 1. And since we're given the vertex here, okay, that tells us we probably want to use that vertex form that we just learned, or that we learned in the previous videos. So the f of x equals a times x minus h squared plus k. And in this case, again, because we know the vertex, recall that the coordinates of the vertex are h and k, we can go ahead and plug those in here for h and k. So we'd have a times x minus -2, and you notice even though there's already a minus, I still put in the -2 since that's what the value of h is, and then plus the value for k, which is 3. And if we simplify that, what we have is f of x equals a times x minus minus here makes a plus, so x plus 2 squared plus 3. And notice we're actually almost done here, except for we're missing the value for a right here, right? So how do you suppose we're going to do that? All right, they gave us another point over here, right? So what we can do is now plug that point in for the input and the output. So we can say that 1 equals a times 0 plus 2 squared plus 3. You can solve for a. And just for lack of space, I'm not going to do it all the way out. But if we do that, I believe we end up with -1/2. I believe. Yeah, it's -1/2. So once we know that, then I'm starting to bleed down the other problem here. We can go ahead and plug that into our equation. So we have f of x equals, again, we know the value for a now is -1/2 times x plus 2 squared plus 3. And that would be our equation for this quadratic function in the first one. Wonderful. Let's look at the second one now. So here we're asked to find the values of b and c so that the quadratic function f of x equals -x squared plus bx plus c, so there's our b and c, has the vertex -1, 1. And again, these are going to be our values for h and k because that's the vertex. So we have to find b and c here. And notice they have given us one value in the equation. So we see that it's a -x squared, which you may recall is the same as -1x squared, which tells us that this value for a here, or excuse me, the value -1 here is the value for a. Okay? So knowing that, and knowing the values for h and k, we can actually start by using our formula for h here. So we know that h is given by -b over 2a. We know the value for h, so we can plug that in. So that'd be -1 equals, we don't know the value for b, so we leave that as -b over 2 times, we do know the value for a, right? That's -1. So this gives us -1 equals -b over 2 times -1. If we then simplify a little bit, we would have -1 equals -b over -2. And we see here that we have a negative over negative, which makes a positive. So we have -1 equals b over 2. Multiply by 2 on both sides. Then what we get is, it looks like we'd have these cancel out. But b equals -2. Okay. All right, so we know that now. We know the value for b. So we can plug that into our equation. Okay, so this equation here now is going to look like f of x equals negative x squared. Again, the value for b, which is minus 2x, and we need to find c now. And we can actually go back to our vertex here, because we haven't used the value for k, and we can still sort of use the value for h, because we know if we plug in negative 1 for x here, we should get 1 as the output. So we can substitute that stuff in. So if 1 equals the negative of negative 1 squared minus 2 times negative 1 plus c. And then notice that in this equation we have now, c is the only variable, so that's good. That means we can solve for it. So here we'd have 1 equals, to be careful with this first term, negative 1 squared is positive 1, but then we have the negative of that, so that would give us negative 1. Negative 2 times negative 1 gives us a plus 2 plus c. Simplify that, we end up with 1 equals 1 plus c. If you solve for c there, I think you'll find that c is actually equal to 0. Okay, so we have found that our values for b and c are b is negative 2, c is 0. And if we were to plug those back in over here, we'd have a function whose vertex is at negative 1, 1. All right, wonderful. Let's look at finding horizontal intercepts now. And recall, just so we remember what they are, horizontal intercepts, we're not calling them x-intercepts since we're not always dealing with x values. Okay, those are points where the function intersects the horizontal axis. So in the case of the one I just drew here, see it has 3 horizontal intercepts. They would be those where those 3 orange circles are. We also know that for any horizontal intercept, the form of a point there is going to be number, comma, 0. So there's going to be some input, could be anything depending on where the point is, but the output would always be 0, which can now help us for these 2 problems we have to the left for finding the horizontal intercepts, because again we know the output is equal to 0. So what we can do with each of these is take and put a 0 in for the output spot. So we have 0 equals x squared minus 3x minus 28. I want to solve for the values of x here. Now it may be tempting to try to isolate the x's, but I'll tell you that will not work. So what we can instead do is factor, okay, which we talked about in our prereq work. So if we do that, this becomes 0 equals, since there's no number in front of the x squared here, besides 1, we can factor this just like we learned before. We'll find 2 numbers that multiply to negative 28 and add to give us negative 3. In that case, I believe the 2 numbers there would be negative 7 and positive 4, which tells us that this should factor to x minus 7 times x plus 4. And now hopefully this looks really familiar because we have 2 things being multiplied equal to 0. We know to solve that we can set each piece equal to 0. And so when we do that, we get x equals 7, x equals negative 4. And then as I mentioned over here, our horizontal intercepts always have the form number, comma, 0. So we'll write our answers here like that. Okay, so because we found x equals 7, we know 7, 0 is one of our horizontal intercepts. And then we also found that x equals negative 4, so we know negative 4, 0 is also a horizontal intercept for that first function. Okay, so it looked like that. All right, let's look at the second one now. And I'm going to start, again, just as before, setting equal to 0, but I'm going to go way up here. So I need some space. So 0 equals 2x squared plus 5x minus 3. And notice this one we can't just factor like we did before, because now the coefficient in front of the x squared term there is now not a 1. We have a 2 there. So how are we going to deal with that? Well, this is where what comes in something that I call the AC method. Okay, because it turns out this can still be factored. We just need to use a different method. And as I go through this, you may know a different way to factor these. When I was a kid in school, they taught us guess and check, which was really annoying. But that is one way to do this. But we're going to try to do this AC method way. So first of all, what I'm going to do is identify where my A, my B, and my C are. And I'm going to start the AC method by multiplying A times C. Okay, so I'm going to do 2 times negative 3, which gives us negative 6. And then I want to find two numbers that will multiply to give negative 6, and also add to give me the value for B, so the plus 5. So what are two numbers that multiply to negative 6 but add to plus 5? I think the answers there would be 6 times negative 1, right? 6 times negative 1 is negative 6. 6 minus 1 is plus 5. And then I'm going to do something that might seem a little strange, but I promise it's okay. Is I'm going to split up this 5x into a plus 6x and a minus 1x. Okay. And notice that's legal because 6x minus 1x would give us a positive 5x. So we actually didn't change the value or change anything about the equation. We just wrote some part of it in a different format. And the next thing we're going to do is take the first two terms there and group them together. And the second two terms there and group them together. And when we do that, then the next thing we want to do is find out what's common between each of those pairs of terms and factor that out. So between the 2x squared and the 6x, looks like we could factor out a 2x, since 2 divides 2 and it divides 6. And because the first term has an x squared, the second term has an x, we can factor out an x. We got to think about what's left over. If we take the 2x out of the 2x squared, that'll just be x, because x times 2x is 2x squared. Take an x out of the 6x, or sorry, a 2x out of the 6x, that would give us a plus 3, because 2x times positive 3 is 6x. And so we're done with that part. And we look at the second two terms, the minus 1x and the minus 3. Well, in this case, it looks like the only thing we can really factor out of both of those, they're both negative. Both terms are negative, and we can factor out a 1. So we have negative 1. If we do that out of the first term, we're just left with x. And then for the minus 3, we got to think about what would need to be inside the parentheses here, so that when we distribute through the negative 1, we get minus 3, and that would be a plus 3. Okay. So now we have 2x times x plus 3 minus 1 times x plus 3. Notice that each term here, so this one and this one, both contain an x plus 3. And even though that's a big term by itself, we can actually factor that whole thing out, so the x plus 3, and look at what's left. So if we factor an x plus 3 out of the first term, right, so if this is gone, we're just left with 2x. If we factor it out of the second term, so this is gone, we're just left with a minus 1. And look, y'all, we have factored this. We have that 0 equals x plus 3 times 2x minus 1. And you can double check that if you FOIL this out, it will give you this. The next thing then is to take each piece there and set it equal to 0. When we do that, we should get x equals negative 3 from the first one, x equals positive 1/2 from the second one. So therefore, we know that our horizontal intercepts are at negative 3, 0, and 1/2, 0. Okay. Isn't that fun? I believe that it was. All right, that last example maybe had a lot of stuff going on. You might want to go back in the video and rewatch it to make sure you got everything. Okay, that's it for now. Thank you for watching.